All right, the last question we have for discontinuity is we've already shown what points are continuous, so now we're going to say on what interval is the function continuous. So we use those points of discontinuity to exclude them, and then everything else is continuous. So we have here as the first is our polynomial, and we already know polynomials are continuous everywhere. So if they give you a polynomial, we know it is continuous from negative infinity to positive infinity. Done. Move on to the next one. All right, rational expressions, we have two different types of discontinuity. We have wholes, and we have infinite discontinuity from asymptotes. So you're looking for both, and how you find those is you first start by factoring. We always factor our rational expressions first, like this, to see if something cancels. And if something cancels, that is a whole. So we get x minus 2 over x minus 2. This means that we have a point of discontinuity at x equals 2. X cannot be 2 because if you plugged in 2, you'd get 0. And this is a whole, so we don't want to forget that. This is a removable discontinuity. Whatever's left is our rational expression that we're going to be graphing, and so that is where your vertical asymptotes occur. So x cannot be negative 2 either, and this is an infinite discontinuity. Okay? So graphically it looks like this. You can see that coming in here at negative 2 we have our infinite discontinuity, and if I hit trace negative 2, you'll see there's nothing there. And then you look over here and you think, oh, well, there's a point at 2. Well, let's look at it. Trace 2. And you see also nothing there. That's a whole. It's just not showing up. So right here is a whole, and right here at 2 is an infinite discontinuity. So our interval that is continuous is we're going to have that same idea. You've got this vertical asymptote here at negative 2, and you've got this whole at 2. So we have our infinite, and we have our removable. And so everything else is good to go. So it is continuous here, and continuous here, and continuous here. So our interval for where it's continuous would be from negative infinity to negative 2, parenthesis, union, parenthesis, negative 2 to 2, parenthesis, union, parenthesis, to infinity. So it is continuous on that interval. All right, so is there a point of removable discontinuity? Yes. That point of removable discontinuity is at x equals 2. But see, we're using the word point, and so we want a point for it. So it's 2 comma what? And how you find that is you just take the x minus 1 and the x plus 2, our g of x, what it's become. So our g of x is now basically this. It's x minus 1 over x plus 2 for x not equal to 2. And it is equal to what when it is, okay? So that is our new value, okay? So if we were to plug 2 into there, it would tell us what our removable point of discontinuity is. So if I plug 2 in here, you get 2 minus 1 over 2 plus 2, and that would be 1/4. So this is our removable point of discontinuity, is 2 1/4. That's your whole. Okay, so last one is just a nice messed up one. I've thrown in some radicals, and I've thrown in some other points. So denominators here, you can't factor the top on either of them. So we know that x minus 1 cannot be 0. We also know that x squared plus 1 cannot be 0. So x here cannot be 1. And if we solve this one, you think, oh, it's going to give us 2 more. Oh, that's imaginary. So your x here is plus or minus I. We don't have to worry about imaginaries on the real number plane. So all we have is x plus 1. But you also have to focus on radicals. Radicals, if they're negative inside, like we have here, you get imaginaries. So that radical, that x, must be greater than or equal to 0. So whatever's inside your radical, you also have to include. So if we draw that line like before, you would see that we start at 0, right? And we have a point, and so I'm going to put a bracket here, or you could put a closed dot. It's your choice. But then at 1, we have an open dot, right? In fact, what we don't even have is an open dot. What we have is a vertical asymptote there. So at 1. And so our region would be from here to here and from here to here. And you're going to see this very quickly on the calculator to show that it works the same way. So our continuous interval would be from 0 to 1, parenthesis, union 1 to infinity. So it is continuous on that interval. And so I plug that into our calculator here. And you can see it here. And you can see at 0, that's where it starts. There are no values over there. So if I hit trace -1, nothing comes out. It doesn't give me any values until I get to 0. And then once past 0, I've got values. And then it goes down to -infinity, up to positive infinity. So at 1, we have that vertical asymptote. So it is continuous from 0 to 1 and from 1 to infinity. And that's our points of continuity. Thank you.